Let's try to solve this problem here. In the circuit diagram below, find the voltage across AB. AB is over here and here. You want to find the voltage across here using the concept of potential divider. So we want to use the concept of potential divider to solve this problem, but we know that potential divider can only be used in a series circuit, but what we have here is not really a series circuit. So what we need to do now is to arrange or manipulate the circuit so that it becomes a series circuit first, then only we can start to apply the concept of potential divider. So when we look at these 4 resistors over here, we can see very directly that these 2 resistors can be combined in parallel first. So when they combine to be parallel, there will be 3 resistors connected in series. So that's the way for us to rearrange the circuit so that it becomes a full series circuit so that we can apply the concept of potential divider. Okay, so before we start, let me just label everything with their respective name. So I'll call this 50 kilo ohm resistor as R1, this 100 kilo ohm resistor as R2, this 300 kilo ohm resistor as R3, this 125 kilo ohm resistor as R4. So I'm now going to I'm going to combine R2 and R3 so that it now becomes R1. Then there will be R23. Then lastly, there will be R4. Okay, so this will be the circuit. So this is R1, this is R23, and this is R4. Okay, so usually I write in the middle, I combine it. So this one is R23, and because this is parallel, so that I'm going to write as 1 over R2 plus 1 over R3 negative 1. So this will be R2 100k plus R3, which is 300k negative 1. Okay, so if I put in this into my calculator, I suppose I'm able to get the answer, which is, give me a second, 75 kilo ohm. Okay, so right now R1 is 50 kilo ohm, R23 is 75 kilo ohm, whereas R4 is 125 kilo ohm. Okay, previously A and B, which is the point of interest that they're looking at, A and B are placed over here. So if it happens to combine R2 and R3 become R23, then point A and B will still be encapsulating the 2 resistor, the 2 initial resistor. So this will be A and this will be B. Okay, so if you're interested to find the voltage across AB, then the voltage across AB is actually just voltage of 23. Because what's in between A and B is R23, so VAB is actually the same as V23. Okay, so if you want to find V23 right now, we can use the concept potential divider because now all the resistors are being connected in series. Okay, so we want to construct the equation for potential divider. We have to make sure who is, we have to make sure who is the one providing who is the input voltage for this case. Okay, for our case over here, the input voltage will be the battery because the energy provided by the battery will be divided across R1, R23, and R4, right? So the input voltage will be the battery. So I'm going to write it as V battery or V input. Okay, who is sharing the energy? R1, R23, and R4, they are all trying to take away, they are trying to divide the energy given by the battery. So all the resistors involved are R1 together with R23 together with R4. They are all in series, that's why you add them up. Okay, who are we interested with? We are interested with 2, 3 only. That's why we only look at resistor 2, 3. So put resistor 2, 3, resistance 2, 3 on top. Then this will allow you to find V23. And V23 is just VAB over here. Okay, so you can plug in the values over here. You have 75K. Down here you have 50K plus 75K plus 125K. And the input voltage over here, it's 30. Okay, so if you calculate everything, I believe the final answer that you get is 9 volt. And since VAB will be equals to V23, that's why VAB is also equals to 9 volt. This allows you to know how much is the potential difference across AB. This would be 9 volt. Okay, you can use the same equation, but if you replace R23 with R1, you get V1. If you replace R4 over here, you get V4. Okay, just let you know how much potential does each of the resistor in the series circuit get divided with. Okay, so R1 will be divided, how do I say it? The 30 volt over here will be divided among R1, R23, and R4. So using this equation, you know how much is divided to R1, how much is divided to R23, how much is divided to R4. Just need to manipulate the numerator and you get the answer of the voltage across the resistor that you're interested in. That's it for this question. Thank you very much.